this video, we're going to look at simple covalent molecules. Simple covalent molecules are molecules that consist of just a few atoms held together by covalent bonds. Examples include water, which is H2O, carbon dioxide, which is CO2, methane, which is CH4, and hydrogen, which is H2. This is one molecule of water. As you can see, we have one oxygen atom covalently bonded to two hydrogen atoms. And the sticks in the picture represent the covalent bonds. Why do molecules of water stay together? In the picture, this shows liquid water, and each one of the molecules is H2O. Two atoms of hydrogen and one atom of oxygen covalently bonded together. But why do these molecules stay together? Why don't they separate and form a gas? There are invisible forces of attraction between the water molecules. These forces of attraction are called intermolecular forces of attraction. Intermolecular meaning between molecules. Now, these are not covalent bonds. The covalent bonds occur between the hydrogen and oxygen atoms, but not between water molecules. The forces of attraction between water molecules are the intermolecular forces of attraction. In order to turn liquid water into a gas, energy is required to overcome the intermolecular forces of attraction between the water molecules. So now this water molecule has been separated and it can form part of a gas. However, as you can see, the covalent bonds between the oxygen and hydrogen atoms are unaffected. It's because the covalent bonds are very strong. A lot of energy would be needed to overcome these, whereas the intermolecular forces of attraction between water molecules are relatively weak. So they don't require as much energy to overcome as the covalent bonds do. This means that water, compared to an ionic compound like sodium chloride, has a relatively low melting and boiling point. Let's compare the melting points of three different substances that have different atomic structures. Water is made of simple covalent molecules, and to melt ice, we need to overcome the intermolecular forces of attraction between the water molecules. Because these are relatively weak, the melting point of water is relatively low at 0 degrees Celsius. In diamond, it forms a giant covalent structure of carbon atoms, and there are many strong covalent bonds between the carbon atoms. So in order to overcome these, we need a large amount of energy. So diamond has a very high melting point of 3,550 degrees Celsius. And in sodium chloride, the sodium and chloride ions form a giant ionic lattice. This means there are many strong electrostatic forces of attraction between the ions, and these require a lot of energy to separate. So sodium chloride has a high melting point of 801 degrees Celsius. From this, you can see that substances made of simple covalent molecules have relatively low melting points. What happens if the size of the molecules gets bigger? Well, let's look at an example of ethane and octane. Ethane has a chemical formula C2H6, and octane has the chemical formula C8H18. And as you can see, octane is a much larger simple covalent molecule compared to ethane. If you look at the intermolecular forces of attraction between octane molecules, they're much stronger compared to that of ethane. Therefore, octane has a higher melting point of minus 57 degrees Celsius compared to the minus 183 degrees Celsius melting point of ethane, because the molecules of octane will require more energy to overcome the intermolecular forces of attraction between them compared to ethane. Generally, as the size of the molecule increases, so does the melting point and the boiling point. Why are substances made up of simple covalent molecules poor conductors of electricity? Well, if I draw the dot and cross diagram of water, we can see that there are no delocalized electrons. Therefore, substances made up of simple covalent molecules cannot conduct electricity. Now I want you to pause the video here and try these 5 questions. Here are the answers. Like the video if you got 5 out of 5 correct.